Alright, what's up guys? In this video we're going to pick up some multivariable calculus, and we're going to be taking a look at another multivariable limit. So we're going to evaluate this multivariable limit, the limit x comma y comma z approaching 1 comma negative 1 comma positive 1, and we got xz plus 5x plus yz plus 5y all over x plus y. So for multivariable limits, again, the first thing you want to do, very similar to what we do for single variable limits, is just try to plug the values in and see what happens. Because sometimes you might get lucky, you stick in your values, you make it a finite value, and you're done. If that doesn't happen and you end up getting some indeterminate form, you have to go to other avenues. So notice here that if we stick in everything, well, we stick in a 1, stick in a positive 1 there, stick in a negative or stick in a positive 1, stick in a negative 1, stick in a positive 1, we stick in another negative 1 there. Notice we're going to get 0 on top, and down here at the bottom, if we stick in a 1 for x and stick in a negative 1 for y, we'll essentially end up with 1 minus 1, which is also 0. So we'll end up getting that 0 over 0, that indeterminate form. So clearly direct substitution here is not going to work. So much like you can do for single integrals, there's a bunch of different techniques that you can apply to try to see if you can evaluate the multivariable limit. Factoring is still in play, factoring things out, expanding some things out, canceling out terms, that stuff is in. If you have square roots, rationalization is still in play. The only thing about multivariable limits that most students hate is that you can't use L'Hopital's rule, because L'Hopital's rule only applies to single variable limits. You don't have that luxury with multivariable limits. So other than that, that's pretty much out. So you're gonna have to come up with some other avenues. There's also another way to evaluate multivariable limits, which is referred to as a two paths approach, which I'll do a separate video on that. So what we're going to do is we're going to try to see if we can kind of factor this numerator here to the point where we can cancel something out. So you're going to have to be a little clever and try to figure out what you can do. So in our numerator here, we got an x plus y down here. So really what I want is I want to try to see if I can get an x factored out and a y factored out, because I got an x plus y down here. So I want to try to factor out at least an x and a y from up here. So if I factor out an x and a y, and imagine if I do it on this side, I factor out an x, and that side factor out a y, because notice we have two y's on this side and two x's on this side. So I'm going to factor out an x, so it's going to be x. And then it looks like if I factor out an x on this side, I'll have x times 5 plus z. And then this will be plus. And then similarly on this side, because I have two y's, so we want to try to get one of those out. So we're going to pull out a y, which means that I'll be left with z plus 5 over on this side. Now recall that since addition is commutative, 5 plus z is the same thing as z plus 5. Okay? So since these are essentially the same thing, I could end up factoring out a 5 plus z from my numerator here, because we got two of them. And so if I end up factoring out one of those for our numerator, essentially what we'll end up with is 5 plus z multiplied by x plus y. So now what I'll do is go back to our limit. So we'll go to the limit, and we'll have the limit x comma y comma z. It's approaching 1 comma negative 1 comma positive 1. And this time what we'll have is 5 plus z multiplied by x plus y, all divided by x plus y. And if you notice here, x plus y's cancel out. So we'll have the limit x comma y comma z, and it goes to 1 comma negative 1 comma positive 1. Essentially what we're left with is 5 plus z, and we just got to substitute in, and we'll get positive 6, which is our limit. So here's your final answer. So your final answer here is 6. That's the limit. And that's basically how you do it. Okay, so you just got to be a little clever with some of these. But it's pretty straightforward. All right, I'll see you guys next time. Let me know if you have any questions. Take care.